Ariel,
Sí, el periódico, la desventaja es que son
Bien.
noticias de un día anterior. Ay, papá.
compañeros, hablen.
Buenos días. Buenos días, Andrés. Buenas
Buenos
tardes.
días, Andrés. Buenas tardes, Andrés. Buenas tardes.
Buenas tardes. Yo, Pepre.
No es que todavía no estaba mis. Tanto como. Ay, que se me caiga. No sé qué pasa, no sé.
Buenas tardes, mamá. Ya estuvo el café.
Igual a mí, fíjense, el día que bebo café no me despierto toda la noche. Sí. Sí, yo no. No, pues hoy fuimos al banco ahí a pagar las obligaciones y de ahí nos venimos para acá. Sí, de ahí trabajando. Sí, igual nosotros, ahí la pura tecnología por teléfono, por computadora, internet, todo eso. Sí.
One, two, hello. Can you hear?
Ya se le escucha, se le escucha.
Okay, let's start. Sorry.
Perfect, Nisar.
Yes, thank you. Now, thank you. So let's start again. Unit circle. The unit circle is a tool useful to compute many trigonometric values. These trigonometric values are summarized in this unit circle. So the interior part, it's something we already did in the class, the division with degrees, the angles we divide, and the radians too. But today we're gonna concentrate more in the exterior part. So in the exterior part, we're gonna see coordinates around the circle. We're gonna see points. What points? Okay, here's the unit circle itself. Look, it's complete. It has the division of the angles we did in the class. Of course, here you cannot see the lines because they are not this one. But today we want to conclude everything which is outside the unit circle, okay? So let's see how we're going to conclude this. I was saying that these 4 points I'm showing you right now in the presentation are important because they give us the idea of why this is called unit circle. It's called like that because the radius of the circle is 1, okay? Every time is 1. So keeping this idea, we can start analyzing and concluding why these values are there and how to get these ones. Again, if you're not gonna speak right now, if you will not speak right now, please mute your microphone, and at the moment you want to speak, do it, okay? So here we go. This is the unit circle, and the unit circle practically, here we have this information, 0, 1, negative 1, comma 0, 0, comma negative 1, 1, comma 0, and those values that are around are the values we're gonna conclude right now. We will see how. So I'm gonna use something which is called spatial right triangles in order to find the values that are in here. For example, here, if you see, we can make a right triangle, and I'm gonna place that right triangle over there, okay? It's a right triangle, 90 degrees. Who can tell me what's the measurement of that angle? Who can tell me what's the measurement of this angle? Nobody?
90.
Oh, it's not 90. 90 is that one. That one is related with this one. Look, with this opening. That's why I overlap that triangle over there. So again, what's the measurement of that angle?
90.
30 degrees.
It's 30. It's 30
30
degrees.
degrees.
Yes, it cannot be 90. Just 90 degrees is until here, look. So 30 degrees will be useful right now to understand what happened with this right triangle. So let's see what's gonna happen with the right triangle. Something else, we know the hypotenuse of this right triangle, which is 1. So using that information, we will conclude the length of that side, the length of this other, and by that way, the coordinates of this point. We wanna care about a lot about this point we have in here. Why? Okay, because this point have the coordinates that are around the unit circle. And it's gonna be the same with the other right triangles we will discover. We're gonna make like 3 right triangles and conclude the values that are part of this unitary circle or this unit circle. Okay, so we need to find the length of that side in order to get the x coordinate. We want to find the y side, that side on the triangle in order to get the y coordinate. So how this gonna be? Check this out. Having this right triangle, we can compare this right triangle with that one, which is one of the special right triangle. In this case, this is called a 30, 90, 60. Sorry, 30, 60, 90 degrees. And if you see they are too similar, okay? This triangle just requires something, that you find the value of x, and finding that value of x, then you can conclude the rest of the missing sides. So this is what we're gonna do. So how can we get that value of x? Simple. Look, right now those doesn't have like the same measurement, but I'm sure, I'm 100% sure this angle here is exactly 60 degrees. Reason is because this angle here is 90, and if you remember, the sum of the 3 angles must be 180. So right now those triangles are very similar, and if you see, this side is something that I don't know, this one is something that I don't know, and the only thing that I know is the hypotenuse. So I can start there using that hypotenuse in the formula or in the special right triangle, and the hypotenuse of the triangle that I have in order to get x, because if I get x, then I can get the other 2 missing sides. Simple like that is work with a special right triangle. How can you get x? Easy. Both are hypotenuse, so both must be equal. That's why 2x, it's equal to 1. Solving for x, then you conclude that x is 1/2. And something else, if x is 1/2, if x is 1/2, then this side is gonna be 1/2 times the square root of 3, which is the square root of 3 over 2. So this information right now is useful to conclude everything about that triangle, specifically that side, this other one, the missing ones. So how this is going to be? We're gonna concentrate with this 1/2, which is related with that side, and this square root of 3 over 2, which is related with this other one. And by that way, I think we already conclude what we need, the measurement of the 2 missing sides, just knowing x. Okay, for what this is useful? It's useful for next. This is the information we conclude right now. Remember that this triangle was in the unitary circle. Now we're gonna return this to the unitary circle, but right now I want that you conclude why we did all that job. To talk about that point which is in here, which makes an x and a y coordinate. The x coordinate related with the horizontal side, and the y coordinate related with the vertical side. So how this is going to be? X is gonna be the square root of 3 over 2, and y is gonna be the 1/2. Okay. How is that in the coordinate plane? Simple like this. If you're not totally clear, I think now you're getting the ideas. I'm plotting that that point, showing right now the x coordinate, the y coordinate, and this is what you have, a point. Who can tell me what are the coordinates of this point? X coordinate, square root of 3 over 2. Y coordinate, 1/2. Okay. Returning to the unitary circle, see how this information fits over there. So it's 30 degrees, hypotenuse 1, That side is the square root of 3 over 2, which is an x coordinate, and 1.5 is the y coordinate. So knowing that information, now we can conclude what is the point that is hidden in here. The point that is hidden is in the x, the square root of 3 over 2, and in the y, 1/2. But if you see, there are some other unknown values that practically relate the same idea in here. And I'm talking about this one, for example. I'm talking about this other, for example. And this one. They make practically the same situation, so you will see almost the same answer, just with a little difference. That difference is related with the sign. And why is different in the sign? Remember, this is a coordinate plane, right? This is a coordinate plane. And in coordinate plane, in the x-axis, you're gonna have negative values. In the y-axis, you're gonna have negative values when you go down. And practically that's why those values we have in here, both positive, now here change, because you move to the left in the Cartesian plane, and then you go up. So that's why is negative square root of 3 over 2, 1/2. Something similar in here. Who can tell me what are the coordinates hidden in here? Okay, nobody? Will be both coordinates, but both negatives, okay? Because you're working in the left and you're working down in the y-axis. So to conclude this one, who can tell me how it's gonna be that point? Because practically it's the same, square root of 3 over 2, 1/2, just that it changed. The signs change. So how is the point? Nobody?
Maybe the -1 by
Negative 1/2.
it's
Okay, the point is next one.
-1/2 and the
The square root of 3 over 2 positive. Yeah, just remember that always, every time you're gonna work first the x and then the y, okay? It's like that, respect that. So practically we discovered some of the values that are around the unitary circle with this trick of the special right triangle. Let's do the same with another one. Look, I'm gonna jump the 45 and I'm gonna work with the 60 because it's a lot of similar of the 30 degrees. So how is that? So how is that? Practically is, please stop playing, guys. I saw what you're doing with your cameras. Please stop playing. Because right now it's a moment for class and this is just like 40 minutes and right now are missing like 20. So I want to hear your questions. I want to hear your doubts about this, what we're doing, because you're gonna do it. I mean, this is part of one homework you're gonna do later. So let's concentrate in this. Let's concentrate in this other triangle. But if you see, I jumped a one of 45, I said, and we're gonna concentrate in this one, which makes an angle now of 60 degrees, okay? And I'm using this because it's a lot similar than the other one. So how this is going to be? Same information we have, and we're gonna get the other two sides, this one and this other one, using this special right triangle. So this special right triangle is same as the other one, just that now you're working first at 60 degrees. But it's the same. It's essentially the same. You can compare the two right triangles, and the way to conclude the missing values is the same like we did it in the other one. So practically here you will see same analysis we did in the other one, getting the x value, which is 1/2, and getting, knowing x, you can get the other two missing sides. So the missing sides will be 1/2 and square root of 3 over 2, but now in a different position. So this is what we have right now, and remember that we're gonna concentrate in here, in the point that this, in this corner of the triangle, which is practically the coordinate, or where is hidden the coordinate of the unitary circle we need. So the x coordinate we have in here is 1/2, and the y coordinate is square root of 3/2. Looking this in the coordinate plane again, we can plot that point and conclude the x coordinate is 1/2, and that the y coordinate is square root of 3/2. So same as the other one, if you see are like those values, just that in different position, right? So same as the other one, we're gonna conclude this information. Of course, x coordinate is 1/2, and the y coordinate is a square root of 3/2. So I want to hear some voices. Anyone?
Mister,
Yes.
here we are going to put first of all the base measure.
Yeah, because always the x goes first. In points, always the x goes first and then the y. And look, this one, which is working horizontally, is related with the horizontal axis. Who's the horizontal axis? X. This one, which is working vertically, is working with the vertical axis. Who's the vertical axis? Y. Okay?
Okay.
Always go x first and then goes y. That's why we work first with 1/2 and then a square root of 3/2. Hey, you, can you tell me what's gonna be the value in here? Someone?
In negative 3/2 and 1/2.
Okay, first the x, then the y. Negative,
Yes.
negative 1/2.
Negative. Oh, okay.
Okay, negative 1/2 and then the square root of 3/2. Same
Yes.
triangle, so same situation, but now you're working in the left, in the x coordinate. So that's why you choose that one, negative. What do you think is gonna happen in here? In this other one?
They're going to invert the values.
The values will be in the same position, just that maybe they will change the sign. That's all.
Okay.
So look, same triangle, same values bad with different sign. Now both are negatives. Why both are negatives? Why they're positive? Okay, remember the thing of the quadrants. This is the first quadrant and the Cartesian plane. This is the second quadrant, third quadrant, fourth quadrant. Remember how the signs works over there. So if you see this situation repeats in here, so we're gonna have something in similar, something very similar here. Just that the x goes positive because you move to the right and then you go square root of negative square root of 3/2 units down, okay? So we almost finished with the values that are around the unit circle. Don't know if you have a question. Don't know if you have any
At
questions.
this point, no.
Excellent. So
At
let's
this point, no.
let's go because it's missing. Talk about these other triangle we're gonna construct in here and are missing 4 values in that unitary circle, and with this we're done. Of course, you have to do this in yours better, much better than what we have in here, of course, because it's gonna be your handwork. It's handwritten work. I need your drawing. Okay. Concentrating in this last one, same idea we have been doing, same work. We will see now a new right triangle, still being a right triangle. Who can tell me what's the angle in here? Who can tell me what's the angle in here?
45 degrees.
Excellent, 45 degrees. So this is the information we have, and with that information, let's see what can we do. The last time we were working with 30, 60, and 90 degrees triangle for the 2 cases we have, but now we have another different kind of triangle, and this is what we're gonna use and do, okay? So here you have it. It's another special right triangle. It's a special right triangle, all 45, 45, and 90 degrees. Some people call this one the right isosceles triangle. It's the same. At the end, we want to apply the ideas that it, or the property that it makes in our triangle in order to get those sides. Something interesting. Both sides will have the same value. So let's conclude what's the value of x, because this is what we want at the end. To get the value of x, We want to compare the hypotenuses, the hypotenuse of this triangle with the hypotenuse of the other one, and concluding this, because those things are equal because both are hypotenuse. Leaving x alone, you pass the square root of 2 to divide, and by that way you conclude something about x. Okay, are missing 10 minutes. I'm gonna go conclude. Knowing this, we can conclude what's x. Look, x is not acceptable like that because work with square root of 2 is not acceptable. That's why I want to convert this 1 over square root of 2 into something different. How? Applying rationalization process. There are some videos that can help you to understand how rationalization process works. The idea is don't work with square roots in the denominator. So cleaning that square root in the denominator, we're going to have this. So practically this expression is our x value. By the rationalization process, we can conclude that x is 1 over the square root of 2. So if we already know x, we already know the missing sides. And as we did it the last time, we can conclude about that point. The x coordinate and the y coordinate. The x coordinate is a square root of 2 over 2, and at the same time, a square root of 2 over 2 represents the y coordinate. So this is the information that we have. And practically, this is what was missing in the unit circle. Same as the other ones. Now you're clear, I think, about why this process goes in that way. And now we finish the unit circles, guys. This is the work I wanted you to do. And the last part of this presentation, in these last 8 minutes we have, I want to teach you how to use this unit circle in order to find some trigonometric values. So let's do that. How to use the unit circle? First, the unit circle is useful to get trigonometric values. The angles in the trigonometric values are important. Practically, they gave you the reference of the value you want to pick, because at the end, get values, sine and cosine, for example, consists just in to pick one of these values. You will see how. So each coordinate has a meaning. And something else is be aware with the measuring, and I'm talking about the angle measuring, because it can work in degrees and it can work in radians. And you have this part inside, and now you understand why the numbers that are around the unit circle works like that. So let's see how to get trigonometric values. For example, each x coordinate, the first coordinate you see in all the points, represents a cosine value. Each y coordinate represents a sine value. The mix of both, like a ratio, like a fraction, mixing both like fraction, you will see how it is, represents tangent, okay? So essentially the formulas we have are these ones. Cosine of an angle is x, sine of an angle is y, and tangent of an angle is y over x. Let's see with one example how this works, okay? I want that we get cosine of 135, sine of 11 pi 6, and tangent of pi 6. Okay, concentrate in the first one. First, you have to locate 135 degrees in the unit circle. Here it is. And then you want to locate the x coordinate. Here it is. So that's the value of the cosine of 135. You don't have to make any calculus. All you have to do is like pick up the value, and that's all. Something similar will happen with sine, just that sine works with the y coordinate. So 11 pi 6 is your reference angle. You have to search for it, look for it. Here it is, 11 pi 6. And then you're gonna work with the y coordinate, which is in that point, in this case, -1/2, and that's the value, the answer of the exercise. Something happened with tangent, but the same procedure. You have to locate pi 6, and then you have to use both values, y and x, because it works with y over x. Y is 1 over 2, and the other one is square root of 3 over 2. So practically, this is what we have. And if you simplify by the EAR operation or complex fraction operation, which is the name, then you have this result. But this result's unacceptable because you have square root in the denominator. So you have to do the same like we did with the spatial right triangle, the last presentation, the last slide. And that procedure is the rationalization. Okay, rationalization is just a way to eliminate this square root you have in the denominator. Okay, so once you have this, you can practically conclude any trigonometric value that involves the values we have in here, the angles we have in here. Concluding a little bit, get sine and cosine values, just need that you pick up x or y coordinate, easy. Tangent require a simplification of a complex fraction or what you call, or what you know, like your operation. And something else, that trigonometric values repeats the value, just changing the sign, because the Cartesian plane let you understand that, I mean, to the left, the x values are negative, down, the y values are negative. This is what I want to explain you with this one. And let's conclude with these first 5 interesting values of tangent. With this, we finish up. Then I think we will have like 30 seconds for your questions. So tangent of zero require that you locate 0, here it is, and concentrate in those values. The x coordinate is, the y coordinate, sorry, is 0, and the x coordinate is 1. I think here it's invert. Here is wrong. It's y over x. We're gonna repair that later, no problem. So how it's gonna be? 0 over 1, which is 0. Oh, here is right, look. Here is totally right, y over x, which is what we want. So what is tangent of pi 6? First locate pi 6, and then you work with this one, with those coordinates. First the y, then the x. Same with cosine of pi 4th, for example. Cosine of pi 4th require that you find the pi 4th and then use the 2 coordinates in order to get the value that you want. Of course, here's some more. The tangent of pi 3rds is the square root of 3. Sorry, I jumped once. Yes, that one. The square root of pi 3rds is square root of 3, but be careful of that with next one. What about the tangent of pi and a half, which is like the 5th value you can get with tangent? It's gonna be 1 over 0, but 1 over 0 is undefined. You can't divide by 0, and that happened only in tangent. In sine and in cosine, you will not have this trouble. Okay, so how to use the unit circle? Just to conclude, what about next situation? Tangent of pi 3rd is a square root of 3. It's exactly square root of 3. How can you conclude this? Okay, locate pi 3rds, which is in here, relate a square root of 3 over 2 divided by 1/2 or over 1/2 by the your operation. You conclude at the end that this is just a square root of 3. Analyze and conclude next. What about the tangent of 2 pi 3rds? Where's 2 pi 3rds? Here it is. Practically are the same coordinates, just that this one is negative. That's why at the end, almost the same operations, but that one becomes to be negative. Something similar with tangent of 5 pi 3rds. 5 pi 3rds, here it is. If you see, almost the same values we have in here and we have in here too. So in the thirds, you have practically the same value, just that the sign will change. That's why here you have 3 similar answers, just that the sign change in some cases, okay? So it's missing 1 minute, and that is all, guys. Do you have any question?
Mister,
Uh-huh.
how do we identify as each value is tangent, sine, or cosine?
No, that's the value that you want to get. I mean, this is gonna be the exercise. One exercise could be get the sine of 120, but I'm telling you, sine.
Ah, okay.
Yes. Other questions? Any other question, guys? Okay. Time is running. Are missing 30
Estoy un
seconds.
poco perdido, Mr.
Are missing 30 seconds. English, please. And I'm gonna upload a YouTube video with all the presentation, all that meeting. So thank you for your participation, and it's time to say goodbye. Maybe next week we will do another one, and I'm expecting that you see first the videos that I send, and then we're gonna have this meeting. Guys, thank you so much for participating, and thank you for your time too. Bye bye.
Well,
Thanks,
mister, thanks for
mister.
your time.
Thank you, Mr.
Bye, mister.
Vemos.
Bueno.